Bill, and Bill was an old student of Dan Friedman's long ago. How long ago was that?
I don't know if asking Bill. I think it was the first decade I was here.
Okay, and so then there was, I think he was at SRI, and then here, ended up in Tufts, where he's turned out to be one of the world's greatest experts on the programming and threads. I suppose we're going to hear something about that, or maybe not. I'm not sure. I haven't read the abstract yet. Sorry.
Thank you for putting the seat down for me, Bill. Thank you.
So that puppy's going to come up?
It should.
Ooh, okay.
Yeah, look at that. Light is, which one's the main light up front?
They're on the
Control.
Oh,
Yeah.
which one is it?
Good question.
I'll show you.
Oh, here. Oh, that's what. How do you turn it from there?
Just press the one for his front. Where's the room? Down here. Board. What do you want, board one?
Front light. That's great. That's on and off. Yeah. Marvelous.
You might have to hit this room control. So
Very fine.
Is that too bright?
No, that is absolutely flawless. Ladies and gentlemen, I come to you before you today with a terrible news. A horrendous plague has come and infested our nation, our programs, our databases. Something most unbelievable, most dreadful. It is, yes, ladies and gentlemen, I refer to none other than the plague of bugs. Excuse me, this is for the camera. Could we rehearse that again? I refer to none other than the plague of bugs. Ah, yes indeed. Ladies and gentlemen, listen to these lamentable stories. Bob.
I once had a bug that segvied every third Thursday in prime-numbered months in leap years.
I had a bug that changed the sex of all third graders named Mason.
Oh, no. And?
I'd tell you about my bug, but it might be listening.
Ladies and gentlemen, no sooner do we destroy a single bug than two more bugs pop up to take its place. Our breakpoint debuggers are hopeless. In the face of this onslaught, nothing we can do can prevent these bugs from coming and sneaking and following us. We need something greater. We need more power. We need omniscient debugging.
You spelled it wrong.
You
spelled it wrong.
Ladies and gentlemen, consider. It is sufficient that we merely record each and every state change in front of a program in order to reproduce that information. The programmer was looking for a bug. All we need to do is record everything that happened, and we'll be able to play it back. We have, in essence, my friends, a time machine. And thanks to the work of some marvelous people who have produced us the Java Virtual Bytecode Machine, it is sufficient to take a simple bytecode like this, put field, add in, right after it, a statement which says record, what the put field did, and we're done. And that takes care of the recording of information. Well, that and a few details. Well, actually a lot of details. Nonetheless, fundamentally, that is what we're after. And now the question becomes, what do we say, from formidable off? Off? Does it work? Let me show you my display. I'm not the first person who thought of this idea, of course, but I'm the first person to really make it work. Consider what we have here. We have a display of all of the method calls I simply record every single method call that happens, and now I can come up to the top of this and say, look at this. There is main. Main calls print line. Print line calls makes a new vector. We call bad method. Who calls worst method? Who calls worst method? Who throws a null pointer exception, which we catch here. And of course, we get to see the classic outline of the run of our program. We understand our program better simply being able to look at it. This program happens to incorporate a multi-threaded quicksort. So if we go over here to a sorter thread, we will see the classic outline of quicksort. And of course, we have multiple sorted threads, this being a multi-threaded quicksort, each thread sorting a smaller and smaller group of items. Down here, of course, we see the threads. We always see the code, so we can simply select a line in the code pane, go to when that happened, as you will notice. There's a little counter up here showing we're on number 37 out of 1,280 events. Selecting any line anywhere brings us to the point of time when that event occurred. Simple. We, of course, have the standard step through the code routines. We can say step over, step over, step over. We can say the old step in, in. So any in to go to. And we can go backwards in time and say step out, 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 out. Which, of course, is a way cool thing to do. Over here, we see the stack frame. So if we are 6 levels deep in a multi-sorted routine, we can indeed see that here we are in average, which is on the bottom of the stack, which is called from sort, which is called from sort, and we can see the sorts as they show up in the main on the side. We, of course, get to see all of our local variables. So here's the variable I. We can say, you know, I would like to step forward. Let's go down here in the main thread where we can see a little bit of output. Look at that. We're going to print everything. We can step forward line by line in the printing routine and see the printing occur. We can see each of those functions run. We can actually bring up the TTY output. And we can see, of course, the TTY output is selected as we go through printing the different items that we're printing. Over here, we get to see the local variables. If we wish, we can say, hey, I would like to see every value that local variable ever took on. I can select one of them and say, go to when it was 14, and boom, there I am. Which is kind of cool. I can show the next value of the variable, moving forward in time, the previous value, the first value of the variable, everything that I am curious about. And finally, of course, there are objects in my routine. Here is a typical object, demo object number 0. If I double click it, it will show up over here on the opposite side, where I could get to see what is inside of objects demo 0. I can recursively open objects. I'd like to see what's in that array. I can bring the array up to the top, where it's easier to deal with. I can say, what are all the values of item number 16? Select that one. I can go forward in time for 16. I can go backwards in time for the entire array. I can show individual changes one by one. You'll notice a little star telling you what changed. I can see anything I want to see. The question then becomes, does it work? I did not actually intend to go to school at Indiana University. I was in the Peace Corps in Kenya, and I was hitchhiking back to California, where I was going to be a grad student in artificial intelligence at Stanford University. But I had a friend, Frank, who was doing physics here, and I stopped in to say hi, and it started snowing. And snowing, and snowing, and snowing. And as long as I was stuck here, I thought I'd stick in and my nose in a few classes. And Danny Paul, when I was a grad student, we always called him that. I don't think we ever referred to him publicly by that term, but well. In any case, he said I could stay in his class and observe, and it was really cool. And he was saying really neat things. And a little lisper, he gave a copy of it to me and said, read this. And the next morning I came back, I was enlightened. It was exciting, it was interesting, it was fun. When I was at Stanford, I had the opportunity years later to use a little Lisper in a class that I was presenting as the fundamental text for introducing Lisp. It worked great, except for the chapter on continuations. Nobody ever got that. Nonetheless, Stanford then wrote me a very nice letter saying thank you, but no thank you. Danny Paul said I could stay here. I continued, got my degree, at the end of which he told me that I should go to SRI. He did not suggest I go to SRI. He did not advise me. He did not recommend or encourage me. He told me to go to SRI, where I went and they interviewed me and they wrote up a job description for me and hired me. And for the next 3 years, I got to do natural language understanding at the greatest AI group in the entire world, where I did happen to learn that I don't actually like AI. It's kind of squishy, and I don't really understand it, and I was expecting a real close analogy between the human brain is doing what it means to be intelligent and what we're doing on computers, and it's a long ways, and it never really. But we did a lot of really cool programming, and I like cool programming. What is this if not cool programming? So I ended up at SRI and subsequently Sun Microsystems, doing marvelous things, sojourned in Europe, made gobs of money, met this girl in Russia, lost gobs of money. I am now a professor at Tufts University, where I am just having the time of my life. And it never would have happened, because consider, I would have gotten a rejection from Stanford, become depressed, taken to the bottle, spent the rest of my life with a dissolute drug diet. Thanks, Danny Paul. And now, let's go find some bugs. The first bug I want to show you is what I call a snake in the grass bug. Because, consider the analogy. If you can see the tail of a snake in the grass, all you have to do is pull the tail, and you get to the snake's head. Huh? And this kind of bug is exactly what we see. Let's take a look right here at a classic snake in the grass bug. If we go to the end of time, we will notice that we have printed out that we have caught a null pointer exception. There we go, null pointer exception. Oh no, that's the snake's tail. Now, why did we get a null pointer exception there? There we can step backwards to where the null pointer exception was thrown. S dot equals, oh look at that, null dot equals. Yeah, that probably is a null pointer exception. Why is that null? Well, S is null, that's what we thought. Why is S null? It used to have a valid value, Joshua. It became null right here because an element here in this V is, it looks like a my vector. Let me close those guys and open up my vector over here. And there we have a vector, and sure enough, element number 2 is null. Where did that come from? Let's step backwards in time and say, who stuck null in there? Ah, right there, look at that. Add null to my vector. Where did null come from? Oh, from another S in another function, unrelated to the previous one. Sure enough, it used to have a valid value. We set it to null because dt.name is null. Ooh, let's go take a look at dt. Here he is, demo thing. And demo thing over here, yes, his name is null. It used to be a valid value. Vladimir, it became null right here because, well, somebody set it to null. Which is a bug. And this is your classic snake in the grass problem. This problem on a standard breakpoint debugger would have taken you a good hour. I know, because it took me a good hour. The reason this is interesting is that with a breakpoint debugger, it's not a snake in the grass problem anymore. It's a lizard in the grass problem. If you have a lizard in the grass, pull him up by his tail, what does the lizard do? He breaks his tail off, he runs away, and you're left with a take a look at a non-snake in the grass problem. In this case, we're going to take a look at right here, this fine little array that we were just looking at a moment ago. If we go to the end of time, we will notice that the array is nicely sorted if you don't count element number 0. Something wrong did not happen, something right failed to happen. We were expecting it to sort and it didn't sort. We could now say, hey, wait a second. I know that I'm looking for a specific pattern now. I'm looking for somewhere in the software that was responsible for doing this thing, and it didn't happen, which is very different from the previous bug. So what was supposed to happen? Well, gee whiz, it's a multi-threaded quicksort. If we pop over here to the sorter threads, we should see that, yeah, this guy is responsible for sorting elements 0 through 19. He made a new thread somewhere, right there, to sort elements 0 through 10. So we can look at that new thread, which is, I don't know, thread 1 here. Yep, he's supposed to sort 0 through 10. And then we could look through by hand and try to find the right thread. Oh, he's in here somewhere. Or we could say, you know, looking for an event in a program run is a well-studied problem. When I was in France, which was just last year, I was chasing the Russian gal across the world at the time. Different story. I worked with Mireille Ducasse, and we worked on exactly this, a prologue-based system which would look for specific types of events in a run of a program. So I can say, hey, show me the first call to the function sort, whose first argument is 0, and I've integrated her work into mine, and so I can say, oh, look at that. There are 4 possible examples of this. I can go a forward search. I worked with RMS a number of years ago, and Emacs, hence everything Emacs is the big, so yeah, there we go, the classic forward search, and I can look for precisely what I'm looking for. This dude was supposed to sort elements 0 through 2. And apparently, he messed up. So I can now go and step through the code and say, okay, what happened? Let's see, I want to, where am I? I want to step into, average of elements 0 through 2, 1 plus 0 plus 237 is 0. Ooh, that doesn't sound good. And now I can step through average and I can say, oh, what's going on? Okay, he's adding them up. Yeah, that's good. So, oh my goodness, look at that. I said, while I is less than end instead of less than or equal to end. And I said, voila. So that's the classic non-snake in the grass problem. We can take a look at one other type of problem, which is what happens when you have 2 threads which hang. Thread number 10 is waiting for demo thing 4. The other thread is waiting for the other demo thing. Let's look at these two. Demo 5 and demo 4. Hello. There we go. Open up, please. We can see that hanger thread number 10 and hanger thread number 11. Go to the end of time. There we go. They are both blocked on a different thing. They're waiting for each other, the classic deadlock. And finally, we go to the front of this. Wait, the front. No, this doesn't look right. Front. Oh my God. Ah, man. Null pointer exception in my debugger. What do you do when you're given a present and there's a bug in your debugger?
Debug it.
What? Oh, use the debugger to... Of course, why didn't I think of that? We want the debugger. Yes, ladies and gentlemen, you have just seen 35,000 lines of highly delicate Java code, all of which is fully instrumented. We can start recording, we can bring up the debugger, we can push the button again, it will throw the exception, we will close the debugger, and we'll bring up the debugger. And now we'll get to go ahead and say, guess what? It looks like another snake in the grass problem. And we can say, come up here please. right here. There we, exception in command, and we can step backwards and look at that. We've got a null pointer exception, which came from here, and it came from here because, etc., etc., etc. We passed a null, this guy returns null, etc. Ladies and gentlemen, I give you omniscience debugging.
I have a quick question. What happens when you have programs that run for half an hour and then they blow up and they've done 10 to the 10th state transitions?
Oh, what about performance? Huh?
Not performance, just possibility.
You know, that's the first time anyone has ever asked me a question like that. Today. Okay. This type of thing is an infinite complexity. There are so many PhDs available for studying this kind of thing. The number one answer is simple numbers. On this machine, it takes 1 microsecond to record the average event.
Sure.
With only 31-bit address space, I can record approximately 100 million events. Start that. And all the rest becomes, on a 64-bit address machine, I can record stuff for 10,000 years. And so it becomes a question of performance. Are you willing to wait 10,000 years if your bug normally occurs in 1,000 years? Are you willing to wait 10 minutes to bring this up if your bug takes 1 minute to run? Or take half a minute to run? So it's always trade-off. The best answers I can give is, number one, I have yet to see a bug that I haven't been able to track down. Sometimes it doesn't work. I debugged Anthony compiling itself. That ran about 7 times slower. I debugged a number of other large programs which ran typically somewhere around a factor of 10 slower. And it turns out there are other issues that come up before that.
So here's a software engineering question. How separated is your GUI interface from the back end that collects and records?
Not near as well as it should be.
Okay, because I know, for instance, that OCaml has some very limited backward.
Yes, I have read some papers on that.
But it's very hard to actually find what kind you're interested in or any of this. You know, it doesn't have nearly the functionality that you have.
That's been my
So it'd be good to
observation.
put that GUI on top of maybe the event recording that they already have.
Appreciate it, thank you.
And also, I guess my other question is, for things like C++, you might want to record a lot more events or record them externally.
Is really complex.
Yeah, you have to
Theoretically,
probably record
we can
them
do it.
outside the program.
Practically, it's.
Yeah.
Well, let's get some. Red.
Okay, yeah, like, does your debugger keep track of the interrelations between threads to, like, debug race conditions and stuff?
Decide? Yes, absolutely.
My first question is follow-up to that. Yes, you can record. First of all, I mean, 64-bit, what you said, is kind of misleading. I mean, because it actually depends on the memory, not on the address space. And so the performance actually becomes bad if you need to swap, because when you swap up, you don't have, I mean, we don't have physical memory for 64-bit, at least not local memory. But the major problem is, it's not like it takes 10,000 years to record the things, but we record lots of stuff in 10,000 years. It means that it's the question of the programmer going through this stuff that's accumulated and finding out this tail of the snake. It's actually would be a needle in the stack. So before we even get to the head, we have to find even the tail of it and how this manifests. So the problem of the complexity is going, we can spend lots of time doing this. But my second question actually points out to the problem. You said, oh yes, we can use the debugger to debug the debugger, it's all great. But suppose if the bug in the recording routine, then how would you debug this recording routine if that is the thing that you use to record it? So you have to trust something. It means that at some point you have to say, well, I mean, the program has to be correct. It means that your debugger would not work if you don't have the trusted core.
Yep.
So we still need to have some kind of a way of, removing all these debugs and writing the code that simply works because it's meant to work.
Ultimately, I am highly reliant on the people who wrote the JVM and the people who wrote the operating system and even the people who wrote the chip that it's running on, the people who supply the electricity, and God who did all the stuff about probability and statistics. So yes to all of those.
Are you trying to say that you don't solve every problem, you just solve a lot of problems?
If I solve your problem, that's enough. So yeah, there are all sorts of marvelous complications. Like I said, there are PhDs for 20 years in here. Jerry?
Again, the other thing is, this, I see this as involves a lot of straight transitions, but suppose we're running mostly functional code. For example, I may have a particular software file that I've written for doing mechanics work. There's probably 10 assignments in about 2,000 pages of code. So there's very, very few actual state transitions that occur. It's all functional. How do you use a debugger like this to help you do that?
I'm not sure. In other words, certainly you see you get to see the entire stack trace of all function calls.
Well, you see that anyway.
Be,
you see that anyway.
That seems to be what I'm using constantly, but I haven't tried precisely that type of program. So the real answer is, I don't know.
Okay, we should talk about that.
Yeah, it'd be wonderful.
But the execution at JDN level would not be purely functional. It's still using your cons, writing different things from every end to let you capture those rights.
Oh, I don't want to know about
Yeah.
those.
That also.
Programs that run for 10,000 years has put me in mind of an upcoming bug. You know, the commercial world thought they solved the Y2K problem by having 4-digit years, but of course we're all waiting now for the Y10K problem, aren't we?
We'll have to resurrect some COBOL program.
Okay. Well, I think